My name's Tom White. I've been working on Hadoop for quite a long time now, about 5 years or so. I wrote the O'Reilly book on Hadoop. That's the cover there. You've probably seen the elephant around a little bit today. And I work at Cloudera, and most of my time I'm spending writing stuff for Hadoop. However, I also work on Whirr, which is what I'm going to talk about today, which is a project for spinning up services in the cloud. There are 4 parts of the talk I'm going to give today. I'm going to talk about what Whirr is. Not many people know about it. It's relatively new. I'm going to show you how you can use Whirr, some of the use cases, some of the kind of practical, concrete steps you need to take to use the project. I'll also talk about, in the third part, how to write a Whirr service. And that means if you've got a distributed system that you want to Whirr enable, so you can run it in the cloud, what steps you have to take to do that. And I'll finish off by talking about the status of the project and what we're going to be doing next, some of the areas we need help in, that kind of stuff. Okay, so what is Whirr? It's an easy way to run services in the cloud. That's the goal of the project. That's what we're trying to solve. And if I describe the scenario, it will clarify it a little more. One of the great things about a conference like this is there are lots of new distributed systems projects that are being talked about, demonstrated. And one of the very frustrating things is you go to a talk and you see an exciting new project and you want to try it out, and then you go look at the web page to see how to use it, and there's a 20-step process to install it. And that might be just for your local machine. So even getting this thing running can be frustrating sometimes. So the goal of Whirr is to simplify that, to make it easy for people who are writing distributed systems to Whirr enable their services, make them easy to run in the cloud. So that's the first aspect here. Try and provide a framework which service writers can use to make it possible to run these services in the cloud. And it needs to be as simple as possible so that they can focus on writing features and improvements for their distributed system, not worrying about the differences between clouds, and all of the complexity that's there. The second aspect is to make it easy for users to actually start these services on demand. And we do that by having a very simple API, a very simple command line interface to Whirr itself. And we'll see that in just a moment. This slide shows the commands you have to type to actually get a Whirr service up and running. Now this is the kind of hello world of Whirr. It's condensed into as short a number of keystrokes as possible. And what it's doing, I'll go through it in a moment, but it's going to start a ZooKeeper cluster. So ZooKeeper is a distributed system which is does distributed coordination. If you wanted to follow along, you can go to the URL in the top right-hand corner, bit.ly/Whirr5, and you can cut and paste those commands, and you can actually have a cluster running yourself. So this is my way of not doing the demo and getting you to do the demo for me. Of course, totally optional. You will need a cloud account if you want to do that. These instructions assume EC2. So let's go through some of these lines in a little more detail. The first step is to do an install, and what we're doing is installing Whirr itself. So we're assuming that you're starting from a bare machine, you've got your laptop. The first line downloads the Whirr distribution, untars it. The second line changes into the install directory. And then the third line, we create a SSH key pair. Whirr uses SSH a lot, and having a custom key pair for your clusters is a very useful thing to do, so we just generate one there. It has to be passwordless, it has to be RSA, so that's the command line you need to do that. Okay, so we've got Whirr installed now. Second step is to actually run the cluster. So we use the Whirr script, and we specify the launch cluster command. And this will launch a cluster which is specified in a configuration file, which we pass to the script using the config option. Whirr comes with a number of recipes. This is the ZooKeeper recipe, and we'll have a look at the contents of that file in a moment. We also need to tell it the private key that we just generated, and we also have to give it some cloud credentials so it can talk to the cloud and start up instances as it needs to. That will take a little while. It will go away, start the instances, it will report progress as it goes, and you'll see some output saying it started instances. It will tell you their IP addresses, all that kind of stuff. When that returns, we can actually use the cluster that we've just started. So in this case, it's a ZooKeeper cluster, so we're going to issue an incredibly cryptic command to it to prove that ZooKeeper is running. ZooKeeper has these 4-letter words, they're called, and I'm going to send it the 4-letter word, "Are you okay?" and it will echo back the answer, "I'm okay," telling me that it's up and running. We don't need to dissect that in detail, but you might notice there's a file there which is in the user's home directory under a .whirr subdirectory, and that's the instances file. And Whirr has created that file to say these are the instances that are in your cluster. So if you looked in that file, it would be a list of IP addresses and other information about those nodes. So that was it. That was starting a cluster. It's very simple. We're trying to make that as simple as possible. So doing it in 5 minutes is a good thing. This is the configuration file, which is specifying the shape of the cluster. So we have a cluster name. Every cluster that you start has to have a unique name. That allows you to start multiple clusters with different names. The second line is a specification of what we call the instance template. Now, an instance template will describe the composition of the cluster. This is a very simple cluster. We have 3 nodes, and each node is a ZooKeeper role. So the second part of that is a role name. In practice, when you're starting more complex clusters, you'll have different roles, you'll have different, you'll have multiple templates. We've only got one template here. If you have multiple templates, they're separated by commas, and you can have different compositions. If you think of a Hadoop cluster, you would have one role would be the name node and the job tracker, another role would be the data node and the task tracker. And then the last block is the cloud provider justification. So what did it actually do when we launched the cluster? Whirr's running on your local machine. It's running in a JVM on your local machine, but it uses JClouds to provision the cluster. And it does it in 2 phases. There's a bootstrap phase and a config phase. The bootstrap phase will start the actual nodes using the JClouds API, and then it will use SSH to connect to the nodes and run some install logic and install script. In this case, it will install ZooKeeper. And then there's a configure phase that runs after the bootstrap phase is finished, which will go through the nodes in the cluster and run a configuration script. And then finally, it will start the daemons on the nodes as well. And so once all that's finished, you've got a cluster running with the ZooKeeper service. The cluster state is stored on the local machine that you launch from. So the instances file that I just mentioned that we use to find out the address to connect to is stored locally. However, that's pluggable. You can actually store that in the cloud, or you can store it in memory. It's up to you. From an architectural point of view, this is what Whirr looks like. It builds on JClouds, and I've actually got a slide about JClouds in slightly more detail. In case you don't know what JClouds is, it's an open source library for interfacing with a large number of cloud providers. And it provides two main APIs to do this. It provides a compute service API, which allows you to manage machines. It does all the things that Whirr needs. It allows you to start machines, query which machines are running, stop machines, actually run scripts on machines, so we use all of those features. And it does that through a uniform API across over 20 providers. It also has a blob store API, which allows you to store data in a key value store, such as S3 would be a common example for AWS. And again, that's a uniform API. Whirr doesn't use that quite as much, but it's nevertheless still useful. You can also write to provider-specific APIs if you need to. We try and avoid doing that. We want our code to be as portable as possible. But sometimes it makes sense to drop into these special APIs or use special features that aren't portable. And a good example is EC2 spot pricing, which allows you to reduce the cost of running clusters. And we really like JCloud because it's very well tested. Before it's released, it's tested on all these clouds. It has a lot of users, so we get the testing benefits from that as well. And it's very performant. If there's a chance that you can run an operation in parallel, it will typically do that. So the implementation is very, very good from that point of view. Also, we like them because we have lots of feature requests which they need and are very responsive to, so that works very well too. So we have JClouds at the base. JClouds provides a number of implementations for providers, as I mentioned. For example, EC2, Rackspace, cloud servers, vCloud. There's another one called, which you probably won't have heard of, which is called Bring Your Own Nodes. And that's a nice one because it allows you to use a cluster of your own machine. So if you had a small 10-node cluster, say, which is a collection of machines in your data center, then you can use JCloud to interface with that. All you need to have is basically have Linux running on them with root access, and then JCloud can talk to them and provision nodes from that pool. So that's quite useful for internal testing, and it can be more responsive than using the other clouds because there's no startup cost. It's also useful if you want to run on your local machine because you can use VMware or VirtualBox along with UION. That's a nice development combination. So above JCloud, we've got three main Whirr modules. We've got the core, which is the user API. We'll see the Java API in a moment. We've got all the services which build on the core. At the moment, we have Hadoop, we have ZooKeeper, HBase, Cassandra, Elasticsearch, Voldemort. There are probably some more that I've missed. We're trying to grow that number of services. We also have the CLI, which sits on top of the stack, which we saw quite at the beginning. A bit about how we organise the development of Whirr. It's an Apache incubator project. It's been in the incubator for over a year now. It was implemented in May last year. And we're just beginning the process of becoming a TLP. So that will allow us to be an autonomous Apache project when that finally happens. We've done 5 releases so far. We've grown in terms of the team who's working on it. We have 10 committers now across quite a few organisations, I think at least 6. We've grown the number of contributors and we're getting more users as well. And one of the nice things we do is have this idea of recipes. So we saw the ZooKeeper recipe. That file was actually cut down. In practice, the recipes have a few more details in them. And it allows us to share best practice in things like how do you select good images on different cloud providers? How do you, what's a good hardware type for a particular service? Which hardware type works well with Hadoop? Which hardware type works well with ZooKeeper? The answers are different to those different services. And also, how do you configure a particular service to run in the cloud? Cloud hardware has different characteristics to regular hardware, and sometimes the default configurations don't work, and Whirr's a good project to share that kind of knowledge. if you're running the demo, don't forget to shut it down. I always do this and then waste some money. Okay, so let's look a bit more at how you can use Whirr and some of the use cases for Whirr. This is the equivalent of the original slide using the CLI, but now using Java. So this is going to do the same thing, written from a Java point of view. Again, it's pretty concise. If we just go through this quickly, the first line is creating a configuration object using the Apache Commons Configuration API. It's using the same recipes file. The second line is creating what we call a cluster spec object, which encapsulates the shape of the cluster that we want to start. And to actually start a cluster, we need a cluster controller object, and then we can, on line 4, launch the cluster using the launch cluster method, passing in the spec, saying how we want the cluster to be. That goes away, starts the cluster, and returns this cluster object, which encapsulates the state of the cluster. In particular, it's got a list of the instances in the cluster with their IP addresses. So the first 4 lines is all very general. That's in the core API of Whirr. There's nothing particular to ZooKeeper so far, apart from the configuration properties file. On line 5, what we're going to do is start interacting with it as a ZooKeeper cluster. So we're using a helper method which is provided in the ZooKeeper cluster class, which actually comes with Whirr in the Whirr service, ZooKeeper service module. And that will take the cluster objects and construct a ZooKeeper host string. And then we can actually start using the ZooKeeper API, and that's on line 6. So the standard ZooKeeper Java API, where you pass it the host's URL, and you'll get back a ZooKeeper object, and you can start using ZooKeeper just as you would any ZooKeeper cluster. Then you do your stuff, and then at some later point you will shut down the cluster, destroy the cluster. And you can actually do that in a separate thread, you can do that in a separate process even, because notice it takes the spec, it doesn't take the cluster object. So all you need to do to shut down a cluster is have its name and the correct credentials. So what I've described really is just a lifecycle API. It's very simple. We have the cluster controller, and it's got a few basic methods to launch the cluster, destroy the cluster. You can list the instances in the cluster. There are a few other operations you can do, such as destroying individual nodes, but basically that's it. And the important thing to note, it's not dependent on service libraries, which means that it's independent of the version of the service you start. So I can start 2 different versions of ZooKeeper using the same code. It's just a configuration option. And so to do that, this is an example of how you actually do that. With Hadoop, you would set a Whirr.hadoop.version configuration option, specifying the version of Hadoop you want to run. Another way of doing it is to specify an actual tarball. So if you've got a custom build of a service and you want to run that, you would pass it in as a configuration. And this is a really nice workflow actually. This is one that I use where I've got a patch that I want to test. So I'm working on Hadoop, I've got a patch that I want to test. I want to test it on more than just my local machine. So I want to look at how it interacts at a cluster-wide level, on 10 machines or something. So what I do is I build my patch tarball. I then specify the tarball as a file URL. So that file is on my local laptop, and Whirr will then realize that it's a local URL, push it into a blob store, and then when it starts the cluster, each node in the cluster will download that tarball from the cloud and use that as the installation. So you can very quickly test changes that you make to the system in the cloud. There's more configuration you can do. You can change service properties as well. There are lots of service properties that you might want to set. For example, on this slide, we can set the trash interval of Hadoop to be 1 day. And the way that works is you have this prefix that Whirr knows about, which in this case is Hadoop common. And then after that, you have the regular Hadoop configuration name. And Whirr understands that, or the Hadoop service in Whirr actually understands that, and will generate the correct configuration for the cluster from that configuration option that you pass to it. So this allows you to completely customize the service that you're running using just the regular properties that it exposes. And then the final way of customizing that people want is to be able to install extra software. And so one way of doing this would be write your own Whirr service, which we'll look at in a moment. But the easy way, if you just want to install a small piece of software, is to edit the script that Whirr uses to do the launch. So what's Whirr useful for? By far the most useful case that I've seen is a small, short-lived cluster that's used by a few people, maybe just one person. I just described a development use case. There's also a use case, and these are often driven by continuous integration tools like Jenkins. We have a job where we start up a cluster, run a bunch of system tests against it overnight, and then shut down the cluster. So that's a very nice way of testing a system over time. So if you wanted to test your trunk build of your system, Whirr is a good way of spinning up that cluster. Another separate use case is evaluating services. That's what I mentioned at the beginning of the talk. All these cool new services, I want to try them now. Arun just talked about Use 2. It'd be great if I could try it out on a cluster. If we had a Whirr plugin for that, we'd be able to do that pretty easily. I've started to work on that, by the way. An example of evaluation is if you want to try out Hadoop for the first time, or you've got some data you want to process, you want to see if Hadoop's suitable for doing so. You can use Whirr to start up a cluster, load some data from S3, do your analysis. When you're happy with it, shut it down. It's not a big risk to do that. And one of the nice side effects of this is it's very reproducible. You can share your data set. That's already pretty easy today with S3. You can also share your cluster details, because it's just your Whirr property file. And you can also share the analysis that you've done. So if you're a researcher, you can share all of this stuff and have other researchers look at it and reproduce your results. Something that's been quite hard to do traditionally. Here are a few use cases that I know about. Cloudera, we provide Whirr in CDH. That makes it very easy to start Hadoop clusters to try it out, as I just mentioned. There's a company called Mixon, which is a bioinformatics company, and it uses Whirr to run an analysis of the human exome, which I didn't know this word until recently. It's apparently a subset of the genome, so the coding part of the genome, and they do individual analyses for people, and they use Whirr to run a job on a small number of machines in EC2, and they can do the analysis in a few hours. Outerthought has a product called Lily, which combines HBase and Solar. It's a storage platform which has built-in indexing and search, and they're building an installer which uses Whirr so that you can install it in your own local data center or run it on cloud using Whirr startup scripts. So now I'm going to talk about how you could Whirr enable your service. There are basically 5 steps in this. You have to look at your service and say, what roles do we have in the service? Then for each of those roles, you'll write a small piece of Java that will coordinate for each of those roles the action to be taken. on the cluster. And that's in Java. That's running on your laptop. And then there's a part which is to write scripts that will run on the cloud itself to do installation, configuration, etc. And then it's a packaging exercise, and you can run it. So let's look at those in turn. I'm going to use Flume as an example. Flume is a service for collecting and aggregating log data. It's actually a project that was started at Cloudera. We recently submitted it to the Apache incubator, so if you're interested, you can go look at it there. Very briefly, it runs agents on a cluster, and those collect the log data, and they send it to a second tier. So we have the agent tier, which runs on. Say you've got web servers, the agent tier would collect the web server logs. The collector tier would aggregate those logs, and then they would eventually end up in HBase. There's also a master node which coordinates the whole thing. So from the point of view of Whirr, we actually have two roles here. We have the master role, which is the coordinating role, and we get that name, Flume Demo Master. And we have a node role, which we'll call Flume Demo Node. And the node can actually be either an agent or a collector. And from Whirr's point of view, it doesn't matter, because the master will dictate that kind of topology. Okay, so we've identified two roles here. The next step is to write some Java to do something for each of those roles. So what we have here is a cluster action handler, which is like a callback interface. And what Whirr will do is call back to this interface whenever it's going to run one of the phases that makes up the launch cluster command. So remember, there's a bootstrap phase and a configure phase. Okay, so the first two lines are just a bit of boilerplate to say what the role name is. The bottom method is called before bootstrap, and that gives us an opportunity to run some code before the actual bootstrap operation takes place. Remember, in bootstrap, what we're really doing is installing software. So we're going to run two scripts here. We're going to say, please run the install Java script, and please run the install Flume demo script. We'll see those scripts in a minute. This is a continuation of the same class. This is overriding the before configure method, which allows us to hook into the configuration part of the lifecycle and say, when you're doing the configuration phase, we want to, again, run a script. And this script is going to do configuration, obviously, of the node. Now, there's a slight complication because if I go back to this slide, the Flume nodes have to know about the master. They have to know what the master's address is. So the question is, how do we discover that? And the answer is, in the configuration phase, we know the state of the cluster because the bootstrap phase is finished and we know what instances are in the cluster. So we can actually get the cluster details from the callback interface. So we can actually get that cluster object and introspect it to discover which the master is. So that's what we're doing here. We're using a convenience method to get the instance matching a particular name, which in this case is the master. And once we've got that instance object, we can find its private IP address, and we're actually going to pass that to the script that we're going to run. So this master address will be the private IP address of the master, which we're going to pass to the node script. Okay, so that's the Java. We'd also write the same kind of thing for the Flume master. So there'd be a Flume master handler class, which I'm not going to show here, but it's very similar. So the last bit of code we need to write is some scripts, a few scripts to start things up, to do the installation, do the configuration. We've already got install Java because it's built-in. It's built into Whirr, so we don't need to write anything now. In the case of installing Flume itself, we have to write a trivial script which just downloads the the tarball installs it, does a little bit of configuration, sets up an environment variable, and that's it. This is the configure script, and this is the one that takes the master's IP address as its first parameter. So if you look at that, you can see master host is passed in as the first argument to this script. And so it just uses that to write out an XML file, which is the configuration language of Flume. And then at the bottom, we actually start up the daemon. Okay, so that's all the code. The next step is just to package it into a jar. It has to have a particular layout. You can do that very easily, obviously, without automating. It actually uses a feature of Java called the service loader facility, which allows Whirr to discover the handlers. So we're basically registering two handlers here, the master handler and the node handler. And then the last step is just to run it. And this is actually very similar to the stuff you've already seen. We create a cluster spec file. If you look at the templates line, the interesting point is there are two templates now. We've got one saying we want to run one master and we want to run one node. And then the CLI launch is the same as before. The Java is very similar to before as well. These first line, 4 lines are the same. The interaction with the cluster is obviously different because it's a Flume cluster. And that shows you how to actually run the service. And the key point here is, just to re-emphasize, is the 2 phases. We've got the bootstrap phase and the configure phase. The bootstrap phase, and in each case it's important to understand that the templates are acted on in parallel. So the Flume demo master and the Flume demo node instances and scripts are running at the same time in the bootstrap phase. Whirr will then wait until that phase is complete before it starts the configure phase. So there's actually a barrier between the two. And that's important so that we can guarantee that property of being able to pass IP addresses so that the configure phase can discover the IP addresses that it's going to configure. Okay, so that's a summary of how to write a service. Finally, I'm going to just go through some of the things we're working on now. Let's just start by talking about some of the challenges that we face. I think the biggest one is complexity. If we just look at it in terms of degrees of freedom, if we look at the number of clouds and multiply it by the number of operating systems, the number of hardware choices in a cloud, the number of images that you can use in the cloud, the number of locations that a particular provider has, the number of services that Whirr supports, and then the number of configuration options for each of those services, we get a very large number. So the configuration space is very large, and dealing with that is one of the things that we think hard about. And that's really where the recipes come from, because we want to cut down the number of known good configurations and have people work on those and not deviate too far from them. And also test those regularly. We have Jenkins jobs that run and test some of our known good configurations over time, because these things can change over time as well. You might find that some of the cloud aspects change over time. Like the image ID has been known for the image ID, the bits of that actual image to change even though the IDs remain the same. So running these things regularly is an important thing to do. The other pattern we see is because the services are doing similar things, we notice a common pattern. For example, we noticed that firewall rules were the way firewall rules were being set up was similar across all the services that we were working on. So we kind of generalized that and pushed that into the core, which meant we could test it better. Then the other challenge we have is debugging. When this stuff fails, it's actually quite hard to debug. And we get questions like, oh, I tried to start up the service and it didn't work, what do I do? And it's, oh, okay, debugging that over email is very difficult. So we've improved our logging a lot. And I think that's happening less now. We get fewer of those emails at least. So the logs are better, and also we have things like being able to recover. So if it gets halfway through the configuration phase and then fails, being able to restart it from that point is a useful thing to do. So that's the kind of thing we're focusing on to make it easier to continue. We'd like to add more services. I mentioned we've got a growing number of services, but we'd like more. I'd like to mention Big Top at this point. It's another new incubator project for packaging and testing portions of the Hadoop ecosystem, and it actually comes out of some of the work we've been doing at Cloudera to build CDH. And one of the good things from Whirr's point of view is that will provide a set of well-tested packages that are known to work together. So it will solve some of the interoperability problems that we've seen. At the moment, Whirr has to make some choices about which versions work with which other versions. So in HBase, that's been especially problematic. We'd also like to support more cloud providers. At the moment, we only test with a few cloud providers, even though JCloud supports 20 providers. We don't run with all those providers. And I think that's driven by user demand. So if users want to use a particular cloud, it should be straightforward because of the underlying support from JCloud, but it still needs testing and reporting back, actually. So people saying, yeah, it worked with this cloud. Finally, the other aspect that we're working on is using alternative configuration management systems. In the example I showed, we were using Bash to do installation, which isn't necessarily the best way of doing things. And we'd like to be able to reuse Puppet or Chef recipes that people have. And so there's a group of people working on Puppet support at the moment. If you want to find out more, you can go to the roadmap wiki page, which goes into great detail about some of the things we're working on and links to the Jira with all the gory details. So if you're interested in contributing, I definitely recommend that you visit that page. Okay, that's it. Any questions? Yeah.
So does Whirr itself care who's a master and who's then not a master in the cluster itself?
So the question is, does Whirr itself care who's the master and who's not the master in the cluster? No, it doesn't. So the roles are determined by the service itself. So if you think about the ZooKeeper example, ZooKeeper doesn't have the concept of a master, it's an ensemble. Each node in that cluster is on the same footing as every other node. So it's not a Whirr construct, it's a construct of the service itself. Sure.
So is there a way to specify existing resort instances when you run Whirr?
Existing what?
Existing resort instances?
Reserved instances.
Yeah.
So the question is, can you use reserved instances? I think you can. I'm not sure actually. I haven't done that. I'll have to check. Any more questions at the back?
Yeah. So we use Elastic MapReduce a lot, and I'm kind of always comparing to some stuff that we're used to working with that. And so the thing I was wondering, have you guys thought about how to have a centralized Whirr server running where you can actually see the state of all these clusters that it's been kind of dealing with? So we're used to kind of be able to log into a console and know, okay, these 5 clusters are up, and that kind of state is kind of shared among all the developers.
Right, so the question is, we thought about having a central Whirr cluster, which says a list of clusters that we've been running.
Right, I mean, it wouldn't need to be a cluster, it would just be a
dedicated machine, right, yeah, a service. Yeah. So I certainly haven't thought of that, but it sounds like an interesting idea. You would run that on the cloud and maybe submit your Whirr requests through it. Is that the idea?
Like the command line tool that says you're behind the web UI or something like that.
Yeah, that sounds like a really good idea. I think, so one of the other ways you can use Whirr that I haven't mentioned is you can you can actually launch from a node in the cloud. So what I described is you launch from your laptop, which is fine if you're using it yourself, but if you want to share it in a team, people often use a kind of gateway machine running on the cloud, which you can instantly launch using Whirr as well. Just spin up a box and then install Whirr on there and then do all your launching from there. And what you're just suggesting sounds like a kind of extension of that idea.
Sure, I guess it would be a matter of just getting the state on the full web page so one
Yeah.
can see what we're
Right. Back.
One of the other things that's a problem with recipes, and we try to use a number of different recipe-based approaches for setting up clusters. And the problem is that we don't necessarily care what cloud center we're using, but we'll try to get something running, and then part of it will be unresponsive, or there'll be some problem, some failing with the cloud center, only in names. But I was wondering, since you guys are collecting all these statistics and all this information on all these different providers, and you got this wonderful API, is anyone putting together sort of like what's available now, or what's sort of the best resource given this data endpoint? Is there any sort of
Right. So I think you're asking, is there a kind of synopsis of the information we're learning about best practice?
Yeah.
Kind of. So I would say that the stuff we've gathered so far is quite small in volume, so I don't think we can draw trends or big picture stuff from that. What I would say though is there's a great blog called Cloud Harmony, which does reports on these kind of things. So it looks at different clouds and for example, it would specialize on the I/O capability of a cloud, the disk speed, reads and write access patterns that a cloud can support, and compares it across clouds. So I'd definitely recommend that as a starting point for best practice there. Question?
If you've launched a cluster and failed to shut it down,
Yeah.
you run that same job to start the cluster again. Are there two clusters, or does it reuse the original?
So if it fails to shut it down, does it reuse the original? It won't reuse the original. It would fail when you try to start it up again, because it notices there's a name clash.
Is there a way for Whirr to like load properties and stuff from like S3 bucket? Because so basically like now one master node which people can use to start clusters and everything, but if that goes down, then I lose all the information about the instances and everything. So that
Right.
shut down, right?
Yeah. So I mentioned, at the beginning I showed that the CLI was reading, the initial example was reading from a local file, and I said that's pluggable, and you can plug that to be backed by S3. And that's useful again for the team case. Okay, thank you very much everyone.